Mutatis, Gaspra, Ida and its little moon Dactyl, massive Eros, astronomers estimate well over 1 million asteroids larger than a half-mile wide orbit in the belt. These rocks witnessed the birth of the solar system.
So we would like to go back and look in the asteroid belt at some of the materials from an earlier stage of building a planet, and maybe even some of the raw materials that originally came together to make the planet. Those are all out there in the asteroid belt.
5, 4, 3, 2. We have engines started. We have the ignition. We have liftoff of the Delta rocket carrying the nearest spacecraft bound for the asteroid Eros.
In 1996, Andy Cheng got his wish. A probe called NEAR, for Near-Earth Asteroid Rendezvous, was sent to orbit asteroid 433, Eros. On its way, NEAR passed a second asteroid, Matilda. This was once a planet in the making. NEAR arrived at Eros in 2000. It orbited and studied the massive asteroid for a year, and then landed on the surface. We'd come a long way since the early days of V2 rockets and Sputnik.
We want to know how many different kinds of asteroids there are, where they are, how many of each type, and then we want to know individual asteroids. What are you made of, and what happened to you when you bumped into or collided with, or even almost got broken to bits by collisions? What happened to your structure? And then up close, you look on the surface. What's happening on your surface?
On their surface, big asteroids look like solid rock. Some, like Eros, are. But most are collections of smaller asteroids and space rubble, held together by gravity.
Some of the recent modeling work that people have done also has shown that asteroids must be much harder to blow apart than, say, a rock would be. A rock would shatter and disperse fairly easily compared to most asteroids. And so that's a lesson for us. If we ever have to deflect an asteroid, setting off a big explosion nearby is probably not the right way to do it.
Eros is of special interest. It's the second largest of the Earth-crossing asteroids. The great majority of asteroids circle the Sun in the main belt, safely out of Earth's way, held in place by Jupiter's gravity. But some are not so well behaved. They cut across Earth's orbit. There are over 500 known Earth-crossing asteroids, and the search is on for more. We want to know where they are because of the impact threat they pose to Earth. But early in Earth's formation, Earth-crossing asteroids rained down on the planet, and it was an act of creation, not destruction. There's evidence they may have brought Earth its oceans of water. But what about the worlds beyond the great swarm of asteroids? Were they formed the same way as the inner planets? And are there any leftover worlds orbiting somewhere to give us clues?
We have very different planets, types of planets, as we get farther from the sun. And that's because as you get farther from the sun, the temperatures drop. And particularly at about 4 times more distant from the sun than the Earth is, we hit a point where water would condense out and become a solid.
With water turning to ice, the amount of matter available to form the outer planets was far greater. Jupiter and Saturn grew so large that they started sucking in the primordial gases from the original dust cloud, swelling them to hundreds of times the mass of the Earth. It's believed that a world the size of the Earth collided with Uranus. Today, Uranus still rolls around the Sun on its side. When did these planet-building impacts come to an end?
I've found a lot of comets, and I've been involved now in the discovery of 21 of them. There was nothing like the night we found Shoemaker-Levy 9. We had no idea how important that discovery was going to be. It made page 23 in the London Times that Carolyn and Gene Shoemaker and I had discovered this comet.
When it was announced that Shoemaker-Levy 9 was on a collision course with Jupiter, it riveted world attention.
In all of civilization, since Galileo first looked through a telescope in 1609, and since he first looked at Jupiter in 1610, this is the first time that we will ever have seen a comet strike a planet.
July the 16th, 1994, Impact Day. Every available telescope is trained on Jupiter.
Yeah, that's it.
Oh my God.
That's it.
Look at that. Look at that.
This is how the solar system was built. Comets hitting planets, comets first hitting each other very slowly, and it's kind of almost an embrace rather than a collision. And then these objects get bigger, their gravity gets bigger, the collisions get faster, and the speed gets higher and it gets more violent. As the solar system reaches its teenage years, it's become a little bit dysfunctional. And finally, when does it end? Well, what Shoemaker-Levy 9 taught us was that it hasn't happened yet.
Here, then, are the gas giants. Jupiter and Saturn mark the current limit of the planet builders' theories. Far beyond these gargantuan worlds lie the ice giants, Uranus and Neptune. But out here, the accretion theory runs into trouble.
The formation of Uranus and Neptune are the greatest mysteries in the formation of the solar system, because everything goes more slowly at greater distances from the sun. So all these processes slow down.
When we try to run the same computer programs out there that we did in the terrestrial planet zone, we don't get planets forming. No matter what we do, we can't form Uranus and Neptune using those kind of models. No matter how hard I try, I can't make Uranus and Neptune go away. They're there, and our models can't make them. So we do indeed have a long way to go before we really figure all this out.